In this video, we will practice solving exponential growth and decay problems. This is AP Precalculus Topic 2.2. If you appreciate this content, please give it a like. These problems are calculator active, so we will use our graphing calculator as needed. Number 1. You invest $5,000 in a mutual fund and its value grows at a rate of 10.5% per year. Part A. How much will your investment be worth in 20 years? When the output value grows at a constant percentage rate, that's exponential growth. So we know the function can be modeled by this exponential model. F of t equals f at k times r to the t minus k, where f at k is just the value of the function at k, and r is the common ratio. The initial investment is $5,000, so f at 0 is 5,000. That's our f at k. We can use this statement to find the common ratio r. If the value grows at a rate of 10.5% per year, we start with r equals 100%, and then we add the 10.5%. If the value was decreasing, we would subtract. So r is 110.5%. We need to convert this to a decimal before we put it into the formula. As a decimal, this is 1.105. Just move the decimal 2 times to the left. Now we can write the function. F at t will equal f at k, which will be f at 0, times r, which is 1.105, to the t minus k power. Well, that will be t minus 0 power, and obviously we don't need to write the minus 0. F of t equals, f at 0 is 5,000, so 5,000 times 1.105 to the t power. Feel free to skip this step. Now we can use the model that we just created to find the value of the investment in 20 years. This will be f at 20, which will be 5,000 times 1.105 to the 20th power. Just put this in your calculator. There it is. In 20 years, the investment will be worth $36,831.174. Part B. How long will it take for your investment to be worth $100,000? In other words, solve the equation f at t is equal to 100,000. We can use the graphing calculator for this. Just type in the model as y1 and type in 100,000 as y2. You can solve an equation on your graphing calculator by hitting the y equals button and typing in the left side of the equation as y1 and the right side of the equation as y2. The solution will be the intersection of the two curves. But before we hit the graph and look for the intersection point, we need to adjust the window. The number of years and the amount of money in the account will always be positive, so x min and y min will both be 0. But what about the x max and the y max? I'm not sure how long it will take for the account to reach 100,000, so I'm just going to put in 20 years for the x max, and I can make that bigger if I need to. For the y max, the target is 100,000, so I need to make sure my y max is above that. So hit the window button, and we will let x min be 0, and like I said, I will set x max to 20 years, and if I need to make that bigger, I will adjust. Y min can be 0, but y max needs to be over 100,000. So I'm going to put 120,000. Let's hit graph and see what we've got. Okay, it's going to take longer than 20 years. So let's go ahead and hit that window button and let's let X max be 50. And hit graph. Okay, now we can see the intersection point. Hit second trace and choose option 5 for intersect. Now move the pointer close to the point of intersection and hit enter 3 times. So enter, enter, enter. And that's it. 30.004. The investment will be worth $100,000 in 30.004 years. Number 2. A certain car is valued at $35,000 today. The value of the car decreases or depreciates at a rate of 15% per year. Part A. How much will the car be worth in 7 years? When the output values change at a constant percentage rate, you are talking about an exponential function, and therefore you can use this model. The value of the car today is $35,000. That means f at 0 is 35,000. That's f at k. We can use this statement to find the common ratio r. Because the value of the car decreases at a rate of 15% per year, we can start with r equals 100% and then subtract 15%. That's 85%. However, for the formula, we must write this as a decimal. So r equals 0.85. Now we can write an equation for the value of the car. F at t will equal f at k, and we will use f at 0, times r, which is 0.85, to the t minus k power. That's t minus 0 power, but obviously we don't need the minus 0. F at t equals, f at 0 is 35,000, so we have 35,000 times 0.85 to the t power. It is okay if you skip this step. Now we can use this model to find the value of the car in 7 years. That will be f at 7, which will be 35,000 times 0.85 to the 7th power. Just put this in your calculator. So there it is. In 7 years, the car will be worth $11,220.198. Part B. When will the car be worth $10,000? In other words, when will f at t equal 10,000? Again, we can solve an equation like this by putting the left side of the equation into the calculator as y1 and the right side in as y2. So type it in like this. We need to adjust the window and find the intersection point. Let's let the y max be the initial value of the car, 35,000. At 7 years, we're already close to 10,000, so I'm just going to put 10 years for the x max. So hit the window, and let's let x max be 10. I think that will be sufficient, and we will put in 35,000 for the y max. Let's hit graph and see what we've got. The solution will be the x value, well, the t value of this intersection point. So hit second trace and choose option 5 for intersect. Move the pointer close to the point of intersection and hit enter 3 times. Enter, enter, enter. So there's your answer right there. The car will be worth $10,000 in 7.708 years. Make sure you include the units. Number 3. the population of a certain city in North Dakota declines at a rate of 4.5% per year for the last 30 years. Let T be the number of years since 2000. If the population of the city in 2022 was 300,000, what was the population in 2010? When the output values change at a constant percentage rate, the function is exponential, so we will use the exponential model. In 2022, the population was 300,000, so f at 22 equals 300,000. We are being asked for the population in 2010, so we are looking for f at 10. The population declines at a rate of 4.5% per year. That means the common ratio R will be 100% minus the 4.5%. This is 95.5%, which when written as a decimal is 0.955. And this is what we will actually use for R. Let's substitute these three expressions into the model. Instead of f of x, we will put f at 22. For f of k, we will put f at 10. We just found that R is 0.955, and then we have the x minus k power. Well, that's going to be 22 minus 10. F at 22 is 300,000. So the equation becomes 300,000 is equal to f at 10. Keep in mind this is what we are looking for, times 0.955 to the 12th power. We are looking for f at 10. So let's just divide both sides by 0.955 to the 12th power. We will get f at 12 equals f at 10 equals 300,000 over 0.955 to the 12th power. Just put this in your calculator. So here's the value of f at 10. In 2010, the population is about 521,292 people. Number 4. You have inherited land that was purchased for $30,000 in 1950. The value of the land increased by 5% each year. Let T be the number of years since 1950. Part A. What was the approximate value of the land in 2010? This is an exponential growth problem, so let's use the exponential model. T is the number of years since 1950. Since the land was worth $30,000 in 1950, then f at 0 is 30,000. The value of the land increased by 5% each year. This will allow me to calculate R, the common ratio. It will be 100%, and because the value increased, we will do plus 5%. So this is a total of 105%. For the formula, we need to write this as a decimal, which would be 1.05. Now we can write the formula that gives the value of the land each year. F of t is equal to f at 0, alright, that's our f of k, times r, which is 1.05, to the t minus k power. So that'll be t minus 0 from here, but we don't need to put the minus 0. But f at 0 is 30,000. So we have f of t equals 30,000 times 1.05 to the t power. This equation gives the value of the land t years after 1950. The year 2010 corresponds to t equals 60, because 2010 is 60 years after 1950. So if we want to find the value of the land in 2010, we need to evaluate F at 60. So that will be 30,000 times 1.05 to the 60 power. Just put this in your calculator. Kabam! In 2010, the land was worth $560,375.577. Part B. When will the land be worth $1 million? In other words, when will F at t equal 1 million? We can solve this equation easily using the graphing calculator. Let's put the left side of the equation in the calculator as y1. In other words, type in this model as y1. Then type in the right-hand side of the equation as y2. In other words, y2 is equal to 1 million. The solution to the equation will be the intersection point of these two curves. We need to adjust the window to make sure we can see what's going on, especially the y max. We need to go all the way up to 1 million on the y max. I don't know how many years this will take, so let's let the x max be something big like, I don't know, let's say 50 years. So hit the window button, and let's let x max be 50 years. We can adjust that as needed, but the y max needs to be really over 1 million. So I'm actually going to put 1,500,000. And then hit graph. Let's see what we've got. Okay, I need to make that x value much bigger than this. So go back to the window. Let's let x max be 100. And hit graph again. The solution will be the intersection point, the x value of the intersection point. So hit second trace and choose option 5 for intersect. Move the pointer close to the point of intersection and hit enter 3 times. Enter, enter, enter. So this is the solution right here. So far we know that the land will be worth $1 million 71.870 years after 1950. Let's figure out what year that will actually be. 1950 plus 71.870 is 2021.870. So the land was worth $1 million near the end of 2021. Number 5. A population of insects doubles every month. The initial population is 300 insects. Part A. What is the population after 9 months? When the output values are doubling, tripling, or quadrupling over equal length input value intervals, it's an exponential function, so we will use the exponential model. The initial population is 300 insects, so f at 0 is 300. When they say the population doubles every month, they are telling us that r is equal to 2. If the population tripled, r would equal 3. If it quadrupled, r would equal 4. This is enough information to write the exponential function. F at t is equal to f at 0, that's the f at k, times r, which is 2, to the t minus k power. That's t minus 0 power, but we don't need the minus 0. F at 0 is 300, so let's fill that in. 300 times 2 to the t power. This model will give us the population of insects after t months. Let's use it to figure out the population after 9 months. In other words, we need to find f at 9. this will be 300 times 2 to the 9th power. Just put this in your calculator. Kabam! After 9 months, there will be 153,600 insects. Part B. How long will it take the population to reach 500,000 insects? In other words, when will F at t equal 500,000? As we did before, we can solve this equation using the graphing calculator. Just put the left side of the equation, which is the model itself, in as y1, and put the right side of the equation in as y2. The solution to the equation will be the x value of the intersection point between these two curves. In order to find that, we need to manually adjust the window first. We know the y max needs to be something bigger than 500,000 to accommodate this number. So I'm going to type that in as a million. But for the x max, I don't know how many months it will take for the population to reach 500,000. So I'm just going to put in, let's say 30, okay, an x max of 30, and I will make adjustments as needed. So x max, let's let that be 30. We don't need to deal with any negative time intervals, so let's let x min be 0. Okay, and let's let the y max be a million. And hit graph to see what we've got so far. Alright, this is good enough. We can see the intersection point right here. Hit second trace and choose intersect, option 5. Move the pointer close to the point of intersection, and then hit enter 3 times. So enter, enter, enter. And that's your answer. The insect population will reach 500,000 in 10.703 months. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.